Good morning everyone. So today we will discuss about group 16. The first topic in group 16 is about oxide. I will present about oxide. My name is Muhammad Nur Hakimi. The second one, also acid of sulfur, will be presented by Nursyazmin. And the last one, sulfur nitrogen compound, will be explained by Nurul Syuhada. The first subtopic in oxide is sulfur oxide. It refers to many types of sulfur and oxygen containing compounds such as sulfur oxide, sulfur dioxide, sulfur trioxide, and others. The most important of which are sulfur dioxide and sulfur trioxide, which both are important in the making of sulfuric acid. Next, about synthesis of sulfur dioxide. Sulfur dioxide is manufactured on a large scale by combustion of sulfur or by roasting sulfide ores in air. So the equation here, 4 iron to sulfide react with 7 oxygen, we form 4 sulfur dioxide and 2 iron 3 oxide. The next way of synthesis of sulfur dioxide is by combustion of hydrogen sulfide. So the equation here, 2 hydrogen sulfide react with 3 oxygen will form 2 water and 2 sulfur dioxide. The last one is by burning of sulfur or material that contains sulfur. So the equation here, sulfur react with oxygen will form sulfur dioxide. Properties of sulfur dioxide. It is a colorless gas with rotten egg odor. It is highly soluble in water. Sulfur dioxide dissolves in water to form sulfurous acid, due to which it possesses an acidic character. It does not support combustion, nor is it combustible. Sulfur dioxide is a strong oxidizing agent and also acts as a reducing agent. Synthesis of sulfur trioxide. It can be synthesized by the direct oxidation of sulfur dioxide to sulfur trioxide in air. So the equation here, sulfur dioxide react with half of oxygen will form sulfur trioxide. It also can be made in the laboratory by 2 stages of pyrolysis of sodium bisulfate. So the first step is by dehydration. We will dehydrate sodium bisulfate to form Na2S2O7 and water. So the second step is by cracking. We use the product of dehydration, which is Na2S2O7, and crack it into Na2SO4 and sulfur trioxide. Properties of sulfur trioxide. It is an acidic oxide and dissolves in water to form sulfuric acid. As such, it reacts with CaO to form CaSO4 and decompose carbonate to evolve CO. It reacts with HCl to form chlorosulfonic acid. It acts as a strong oxidizing agent. The use of sulfur oxide. Sulfur dioxide is used in preparation of sulfuric acid and sulfur trioxide. It also used as an disinfectant, a refrigerant, bleach, and also food preservative. The use of sulfur trioxide is used in the preparation of sulfuric acid and also other chemicals. It is an important reagent in sulfonation reaction. The second subtopic here is about oxide of selenium and tellurium. Selenium forms 2 oxides, which is selenium dioxide and selenium trioxide. Selenium dioxide is formed by the reaction of elemental selenium with oxygen. So the equation here, selenium react with 8 oxygen to form 8 selenium dioxide. It is a polymeric solid, therefore monomeric selenium dioxide molecule in the gas phase. It can be dissolved in water to form selenous acid. Unlike sulfur, which forms a stable trioxide, selenium trioxide is thermodynamically unstable and can be decomposed to the dioxide above 185 degrees Celsius. So the equation of decompose is 2 selenium trioxide will decompose to form 2 selenium dioxide and oxygen. Selenium trioxide is produced in the laboratory by the reaction of anhydrous potassium selenate and sulfur trioxide. So the equation here, sulfur trioxide react with potassium selenate to form K2SO4 and selenium trioxide. Properties of selenium dioxide. It dissolves in water to form selenous acid. It reacts with base to form selenite salt containing the selenium trioxide 2- anion. Selenium dioxide is a one-dimensional polymer, while in the gas phase, selenium dioxide is present as dimers. The use of selenium dioxide. It can be used as an organic synthesis. It also can be used as a colorant. Tellurium dioxide is a solid oxide of tellurium that can be found in two forms. The first form is the yellow orthorhombic mineral telluride, or BTeO2, and the second one is the synthetic colorless tetragonyl or paratelluride. Most of the information regarding reaction chemistry has been obtained in studies involving paratelluride. Paratelluride is produced by reacting tellurium with oxygen. So the equation is tellurium would react with oxygen to form tellurium dioxide. Chemical properties. Tellurium dioxide is barely soluble in water and soluble in strong acid and alkaline metal hydroxide. It is an amphoteric substance and therefore can act as both acid or a base depending on the solution. The last one is about chalcogen oxohalide. Oxohalide are a group of chemical compounds in which both oxygen and halogen atom attach to another element A in a single molecule. They have the general formula of AOMSN, which is S equal to fluorine, chlorine, bromine, and iodine. Sulfur from oxohalides such as thionyl chloride, sulfuric fluoride, sulfuric chloride, and thionyl tetrafluoride. Thionyl chloride can be used as a dehydration agent as the water molecules are converted into gaseous product leaving behind the anhydrous solid chloride. So the equation MgCl2 with 6H2O react with 6SOCl2 from MgCl2 plus with 6 sulfur dioxide and 12 hydrochloric acid. Selenium and tellurium form similar compound and also the oxo-base species, which is F5AOAF5, which is A, it can be as sulfur, selenium, or tellurium. They are non-linear with the AOA angle of 142.5 degree for sulfur, 142.4 degree for selenium, and 145 degree for tellurium. The tellurium ion, known as teflite, is a large and rather stable ion useful for forming stable salt with large cation. So I will pass to Nursyazmin to continue.
Okay, thank you, Hakimi. Good morning, everyone. My name is Nursyazmin bin Muhammad Chauthillah. Today I want to present about oxoacids of sulfur. Actually, what is oxoacid of sulfur? The sulfur oxoacids are chemical compounds that contain sulfur, oxygen, and hydrogen. Examples of sulfur oxo anions. First, sulfide SO3 2-. Next, sulfate SO4 2-. Next, thiosulfate S2O3 2-. Next, dithionite S2O4 2-. Next, dithionate S2O6 2-. Examples oxoacids of sulfur. The first examples oxoacid of sulfur is sulfuric acid H2SO4. So you can look at this structure, sulfuric acid. Next, dithionic acid H2S2O6. Next, thiosulfuric acid H2S2O3. Next, sulfurous acid H2SO3. Next, thiosulfurous acid H2S2O2. Next, dihydroxy disulfane H2S2O2. Next, peroxide disulfuric acid H2S2O8. For the next subtopic is synthesis oxoacid of sulfur. Just like I said just now, there are many oxoacid of sulfur, but I choose sulfuric acid to explain more detail because sulfuric acid the most famous oxoacid of sulfur. Okay, synthesis of sulfuric acid. Sulfuric acid is produced from sulfur, oxygen, and water via the contact process. The raw materials needed to make sulfuric acid are sulfur, water, and air. Stage 1. Making sulfur dioxide. In the first stage of the contact process, sulfur is burned in the air to make sulfur dioxide. So look at this equation, sulfur plus oxygen to produce sulfur dioxide. In the second stage, making sulfur trioxide. Sulfur dioxide reacts with more oxygen to make sulfur trioxide. In stage 2, the conditions needed for it are a catalyst of vanadium 5 oxide V2O5, a temperature of around 450 degrees Celsius, chosen as a compromise temperature, giving a decent yield with a good rate of reaction. A pressure of approximately 2 atmosphere, the increased pressure favors the formation of sulfur trioxide. But if the pressure is too high, the risk of explosion is too great, given that sulfur trioxide is highly acidic gas. The direct addition of sulfur trioxide to water is highly exothermic and leads to the formation of clouds of sulfuric acid. This is highly dangerous. In industry, sulfur trioxide is added to highly concentrated sulfuric acid to form a highly corrosive liquid called oleum to minimize the risk. So oleum is H2S2O7. So the sulfur trioxide plus sulfuric acid to produce oleum. Water is then added to the oleum to form sulfuric acid again. So oleum plus water to form acid sulfuric again. In stage 3, making sulfuric acid. In the final stage, sulfur trioxide reacts with water to make sulfuric acid. So maybe some of you maybe did not clear how this contact process actually occur. I provide the video to make it more clear about the contact process. So you can look at this animation. So this is how the contact process occur in the industry. Okay. For the next subtopic is physical and chemical properties of sulfuric acid. Physical properties of sulfuric acid. Sulfuric acid is a thick, colorless and oily fluid. It has a specific gravity of 1.84 at 298 Kelvin. The boiling point of the acid is 611 Kelvin. The higher boiling point and thickness of this chemical is due to hydrogen bonding. This strong chemical reacts with water vigorously, releasing quite a lot of heat. Thus, you must never add water to sulfuric acid. Instead, you should add the acid to water slowly with proper stirring. Chemical properties of sulfuric acid. Reaction with carbon. Hot concentrated sulfuric acid oxidizes carbon as bituminous coal and sulfur. So this is a question, the equation. Okay, for the next chemical properties is reaction with sodium chloride. It reacts with sodium chloride and gives hydrogen chloride gas and sodium bisulfate. Next is electrophilic aromatic substitution. Benzene undergoes electrophilic aromatic substitution with sulfuric acid to give the corresponding sulfonic acid. Okay, the uses of sulfuric acid is first as a manufacture fertilizer. The second uses of sulfuric acid is manufacture of detergent. Next is manufacture pesticide. Okay, next manufacture of synthetic fiber. For the last uses of sulfuric acid is manufacture paint. Okay, thank you everyone. So for the next presenter, I will pass to Syuhada.
Alright, thank you, Shazmin. I will continue my presentation with sulfur nitrogen compound. Sulfur nitrogen compound is a neutral heteroatomic ring and cluster compound of the p block elements include cyclic tetrasulfur tetranitride. Sulfur nitrogen compound can be synthesized. One of it is tetrasulfur tetranitride can be synthesized by passing ammonia through a solution of sulfur dichloride, just like the equation given. Other than that, disulfur dinitride, which is also a sulfur nitrogen compound, can be prepared when tetrasulfur tetranitride vapor pass over hot silver wool. Tetrasulfur dinitride can be prepared by heating tetrasulfur tetranitride with sulfur and carbon disulfide at 120 degrees Celsius and increase pressure. Chemical and physical properties of sulfur nitrogen compound. For tetrasulfur tetranitride, it has a pale yellow-orange in color, vivid orange, and opaque crystals. It has melting point at 187 degrees Celsius. Tetrasulfur tetranitride is endergonic. What does it mean by endergonic? Endergonic almost the same with endothermic, which is heat is absorbed, but endergonic refer to relative change in the energy of a system and may decompose explosively. Other than that, chemical properties for tetrasulfur tetranitride is thermochromic. The thermochromic is properties of a substance that change their color due to a certain temperature. For tetrasulfur tetranitride, it changed from pale yellow at negative 30 degrees Celsius to orange at room temperature to deep red above 100 degrees Celsius. It's stable in air but unstable in thermodynamic sense. For disulfur dinitride, it is more sensitive and explode above room temperature. It can form a polymer of disulfur dinitride, which is exhibit metallic conductivity and becomes superconducting below 0.3 Kelvin. It also a superconductor without metal constituent. For its chemical properties, when allowed to stand at 0 degrees Celsius, disulfur dinitride transforms into bronze-colored zigzag polymer that's more stable from its precursor. Alright, for tetrasulfur dinitride, it has a dark red needle-like crystal, melt to dark red liquid at 25 degrees Celsius and decomposes explosively at 100 degrees Celsius. For its chemical properties, I didn't find the detail about it, so I just put dash to it. Okay, the uses of sulfur nitrogen compound. Tetrasulfur tetranitride can be used to synthesize nitrogen heterocycles, while for disulfur dinitride can be used as fingerprint developer. That's all. Thank you.